Ladies and gentlemen, now we move on to our next session entitled Innovative Sustainable Solutions, the Carbon Space Way. This session will be delivered by Mr. Izzet Zamri, Key Account Manager Asia and Senior Business Development Manager Carbon Space, a leading global platform utilizing advanced satellite monitoring and AI technology to measure and track carbon footprints with precision and transparency. With extensive experience in sustainability solutions across multiple industries, Mr. Izzet plays a pivotal role in supporting organizations to integrate data-driven approaches in their carbon management journey, bridging innovation and climate action. Please join me in welcoming Mr. Izzet Zamri to the stage.
Hello. Good afternoon, everyone. I know it's the last session, so we're leading into the sleepy zone right now, but I think this is a good time to sort of look inwards into tech. I guess it's the best time to look at more complicated slides, to look at more heavy on technical aspects of monitoring. These are things that you'd love to see when you're sleepy. So for this, I'd love to introduce myself first. My name is Izzet Zamri. I am the Key Accounts Manager and Senior Business Development Manager for Carbon Space. We are a DMRV and atmospheric MRV. MRV, for those who may not know, is a monitoring, verification, reporting, and service and platform. We basically help you do your carbon accounting, help you conduct your feasibility studies for interventions, for any insetting work or offsetting work that you are looking to do. Carbon Space is unique in the way in which we are doing things in not how many MRVs are doing it. MRVs nowadays are snapshots, basically. If you want to see what the trees are like this year, it's different from the trees of next year. That's basically a snapshot. What Carbon Space does, how we work is we are working more on net ecosystem exchange, which is a continuous monitoring throughout the entire period. We are a movie, we are not a snapshot. So current practices today, as you can see, that we have individual accounting. If you want to do soil sampling, if you do any sort of individual pool accounting, there's so much room for error. And this is evident in a lot of the work that we do nowadays in if you want to do in the project development design of your offsetting interventions or even your insetting work that you want to do for your CPGs, your supply chains. There's so much error, and so you can see if you want to account for above ground biomass, below ground biomass, soil organic carbon, and dead organic matter, there is a range of estimated errors that come about once you do this individual pool accounting. And you add them all together, you get an enormous amount of accumulated error. And that's something that really affects the work that you want to prove, or even your buyers. It's hard to convince them when you have such a large amount of error due to these individual pool accountings. Existing methods have always been this way, and it's also very hard to justify when you want to make new activities on these sites. So moving on, is we want to see, evidently there's a new practice that we need to do. Something needs to change. We cannot continue working this way. We need to find a way that can improve our methods exponentially without this individual error, without the individual pool accounting. And thus, I introduced Net Ecosystem Exchange. It's previously been used a lot in research and universities, but we have found a way at Carbon Space to make it more adaptable for commercial use and for our CPGs out there, for our supply chains, for even your plantations. which we focus a lot on. Personally, I just got back from a trip in Sumatra, and for a large peatland area, and the application itself has become pretty simplified because of the work that we are doing now. We have found that if you can install a flux tower, a flux instrument, and for those who are unfamiliar with this, a flux instrument is about this high of a machine that can detect the carbon stock of a area based on the wind and based on the atmosphere in that plantation. So if you had like a young palm oil and you had an old palm oil, young palm oil being 5 to 9 years, and maybe an older one, 15 to 20 years, you could then see the sequestration, the amount of carbon dioxide that's being absorbed from both sides based on where the wind is blowing into its air detection system. So here you can see that we also utilize remote sensing and AI to actually help us out in this accounting. And it accounts for ABG and above ground biomass, below ground biomass, and dead organic matter. It counts for all of it because it's something that's happening in real time, and our data then is implemented onto a platform where you can see in real time on our UI. It's a service then you can check on, your investors can also check on to the software and see where the information is coming from. Historical data, we can go back to 25 years, back in the year 2000. We can also see if you had any natural disasters, any activities that happened on the site itself. You can see the effects of it before and after those activities. Okay, so Carbon Space is a global leader in ecosystem-based measurement to monitor, report, and verify carbon. How we do this, as mentioned, is you can see that's an example of a flux tower. Typically, what we do is that we look for the flame towers on the plantations, and then we can attach it on top of these towers. There's remote sensing, and then we also verify through literature studies, and we also verify through the global fluxes. So to understand better, is this flux tower is not just detecting a range or a radius, it is also connecting with other flux towers and other data to minimize and mitigate that error. It is also detecting through these flux informations, it's also confirming with literature studies online to make sure that we are not guessing or creating our own data points. We interpolate the data within the area to the entire region of the plantation, and it absorbs, it detects continuously throughout. So it's about 10 hectares per second. It's quite fast, and it's moving continuously. It can detect the moisture even in this room itself. If I put up a flux tower right here, it can see how much moisture and how much carbon dioxide is being absorbed or sequestered within this room. So this is what the essence of eddy covariance is, and we can see it's been used quite popularly for a long time, but here in Southeast Asia, it's still in its very young and new stages. So at Carbon Space, our data is certified with peer reviews, and we are also ISO 14064 certified. We are also a great partner of Control Union. We have been a strong attendee of the SAC for many years. All of our data is also verifiable with SBTi targets. So if you have these targets with your companies, this is something that would strengthen confidence with your investors and also give more justification for interventions, any sort of work that you want to do with your plantations or your assets. Here's some case studies really quickly. I'd like to show on Polygon A, if you can see, that is a mature palm oil. You can see mature palm oil being more than 10 years old. It does sequester minus 23.9. That is negative NEE. Negative NEE meaning a sink, and therefore this is something that our client here, they did some sort of intervention, whether it be biochar onto the soil. We can see that there was something happening there. There was a positive impact there. Positive impact, but negative in NEE. Polygon B, we have young palm oil, slightly less, but still sequestration. As you can see, it's minus. And then for polygon C, there's a cleared land that was newly planted. You can see that means emissions. If it's positive, means that it just got cut down or some sort of disaster, a fire had occurred in that area. And polygon D is the conservation forest, where a certain area was put aside for biodiversity or some other reason, and you can see the amount of sequestration that occurs on that land. So with our methodology, we have found that this is really effective in seeing the net ecosystem exchange fluxes, the ins and out, the sinks and sources. And with that, yeah, thank you so much. And that was my quick presentation on flux and net ecosystem exchange. Thank you.
Thank you very much, Mr. Ismet Zamri, for that insightful and forward-looking presentation. Your sharing on the Carbon Spaceway has truly highlighted how technology and data can accelerate sustainability